Welcome to the show, Henry. We're so glad to have you. And could you tell us a little bit about yourself?
I'm Henry O'Connell. I'm the co-founder, CEO of Canary Speech. And a story about myself is best told in how it intertwines with Jeff Adams, my co-founder. Jeff and I met 40 years ago. He was at the NSA at the time. I was at the NIH. I was doing research in neurological diseases, and Jeff had a much cooler job. He was building mathematical models to de-encrypt spy messages during the Cold War. Um, and when you think about speech and language, foundational, that's the foundation of speech and language. Jeff went on to working with Ray Kurzweil to build the first commercially available NLP product, speech to text. He led the team at Nuance to build Dragon Naturally Speaking. He, at that time, also built speech to text for legal dictation. And a few years after developing just novel technologies in speech, Amazon was looking for a team to build the Amazon Echo, Alexa. And they simply bought the company Jeff was in. And Jeff and 17 speech and language scientists and another Jeff O'Neill, a PhD patent lawyer with a PhD in machine learning, became the 19 individuals that were the core that went on to launch 3 years later the Amazon Echo, far-field speech. So Jeff and I were friends for 40 years, knows my family well. I know his family well. In fact, I knew his wife before they met and got married. And that's who I am. Before this, I did corporate turnarounds. I worked on a basis of being recruited into difficult situations as an interim CEO.
How did the Canary come along? What was the idea behind that?
Jeff and I, 9 years ago, met in a bagel shop on University Avenue near Brigham Young University. He had been speaking to the college, to students that day, and at noon we met for lunch, a meeting that turned into closing down the bagel shop at 6 p.m. And we were talking about the opportunity to work together, something we might do together. And we spent the first hour and a half talking about an idea that Jeff had to create an engineering firm that would tackle all comers in speech, things that had never been done before, things that were on the edge of impossible. He created that. I helped him with that. It's called Cobalt Speech. Still exists today. But at the end of that description, knowing Jeff and the admiration I have for him and his impact, I said, Jeff, this is a great idea. It's an engineering firm. It'll pay the bills. But what do you really want to do? Of all the things you have done, what's left in front of you? And he said, I'd always wanted to apply speech and language to the analysis of human condition and disease. And so I said to him, why don't we do that? And then we talked for another couple hours about where the field was, and the attempts to use NLP, textual analysis to analyze for disease had 25 years of some progress, but no commercial products. Accuracies weren't there. The breadth of application wasn't there. The amount of data you needed in order to accomplish it was insurmountably high. You just couldn't get it from a doctor-patient relationship, And so I related to him a story about my daughter and who he knows well. And when she would come home from high school after soccer practice, walking across the room, I could tell from her gait that it was a good day or a bad day. When she turned and looked at me, her facial expressions told me even more. And when, as a parent, I would ask the question, which we all do, and the answer we all get is the same. I'd ask her, how was your day? And her answer was fine. And she would continue to walk. And I knew it wasn't. So I would say, time out, and bring her back. And we would talk. And was it chemistry? Was it math? Was it the soccer coach? What was it? And I said to Jeff, as you know, Caitlin has graduated from college. She's married. She has her first child. Not my best day. I'd still have her living in the home, but she lives with her husband and her child outside. And I said, something that I've noticed, I call her twice a week, I'll admit at least to that. And when I call her, and it has nothing to do with the words that she's speaking, and it's irritatingly accurate. And I don't have the physical cues. I can't see her face. I can't see her gait. I can't see her body language. I know if it's a good day or bad day. I know if she's happy or she's sad or she's excited. I know all those things. And I said, I believe that's what clinical team and patients do with patients every day, every single day. They're sitting with them and the patient is telling them one thing, and their intuition, their training, their expertise, their experience tells them something else. And they begin to explore that path with a patient to get to a diagnosis. I said, if we're doing that, how are we getting that done? And Jeff said, I don't know. And I said, if we could determine that and we could model that, that would be a tremendous companion for a clinical team. An objective measurement of the same things they're reading themselves, just a confirmation. So that's how Canary Speech got started. And Jeff had already multiple times in his life created things that never existed before. I had managed companies through hardships and difficulties, and startups often have those situations. So we decided we would try to do that. That's how Canary Speech got born. Then my daughter named the company and she created our logo.
Could you walk us through a little bit about how this works? I know a lot of it is proprietary, but could you tell us a little bit about, just kind of in general terms, layman's terms, what this is doing, and how, if you know how it's doing what it's doing?
Sure. And we're pretty much an open book now. We have 22 issued patents in the US and around the world, and 16 pending. What if you think about it, the way NLP works is not listening to words, of course, because words don't exist yet, not within the context of the tool. It's listening to the primary data layer. And words are at the very best a tertiary level of data. Generally in science, you wouldn't use a tertiary level of data for primary information. You would seek to have primary data. So that we already knew that there was a set of features in speech, and historically that was looked at in more physical terms, jitter, vibrational characteristics of the vocal cords. My background, when Jeff started talking to me about this, my background was its connectivity to the central nervous system. So we have a set of central nervous system commands that drive the most complex motor function that the body produces that results in language. The respiration, our tongue, our cheeks, our movement of the vocal cords, the musculature around it, all of it is self-conscious. All of it's driven by the central nervous system and creates language in hundreds of different languages in the world. But the core elements that drive all of those languages are the central nervous system control of the instruments of the articulatory system. So we came to understand that, and I'm not sure how, but Jeff, of course, had a lot of experience, and we came to understand that, and we started modeling what we called and was already recognized as vocal biomarkers. So there are 2,590 features of speech, the core features plus their derivatives, that we track every 10 milliseconds. Now, functionally, we're tracking them every 25 milliseconds with a 10 millisecond slide. It generates about 15.5 million data elements every minute of speech. We generally analyze with about 40 seconds of speech. What we did was we pulled all of those feature sets out of audio in concert or in partnership with clinical institutions, Harvard, Beth Israel, Hackensack Meridian, NYU, many of them in the US and in other parts of the world, the National Institutes of Health in Japan, several in Europe. So we're working with these institutions that are analyzing or diagnosing disease in a specialty group. If it's Alzheimer's, it's a neurology group. If it's behavioral health, it's a group of psychiatrists. And we pair up with them the capture of audio, 40 seconds from each participant, and their diagnosis, which is the label. The label is the determination of the specialty team, the clinical team. We then take those, extract these features, millions of them, 12 and a half, 15 million features, and machine learning likes that large data set. And then we match the diagnosis with the features and build an algorithm. And then the question arises, how applicable is that algorithm across populations, across languages, across accents? And we can talk about that later, but all of that comes from due diligence and science. Then the rest of it is after training a model, you test that model and its accuracy against different populations. And we've done that in different, for instance, English models are tested in the US, Canada, England, Ireland, Australia, in English as a second language. And we tested across all 50 states to know that accents don't impact on it. So once you've captured the audio, and we can talk about how we make that practical in a clinical environment. Once the audio is captured, it takes milliseconds to process it and return scores in real time. So the clinical team can effectively have information about a dozen or more diseases while they're still sitting with the patient. Kind of like a blood profile, they have a vocal profile.
Does the age makes any difference? Because as you know, as we progress from childhood to adulthood, our voices, sometimes changes. Does that makes any difference or no?
So we believe it probably, you have to prove it does or doesn't, but from puberty to adulthood, 90 years old or older, it doesn't seem to make any difference once that occurs. You can get contributing factors like comorbidities rather. That can impact on analysis. If there's some physical damage to the voice, that can impact on an individual's ability to create language and therefore potentially affect the analysis. We don't bump into that a lot. The vast majority of people can take a test and get an analysis. We're currently engaged in building our first series of childhood models, 9 years in. And we waited intentionally because of the sensitivity to that population of individuals. We wanted everything else in place. But we're currently working on ADHD, autism, and behavioral health models, anxiety, depression, and fatigue, and other things for children, with 4 different groups in the world right now.
Is the difference between gender like male and female or?
None. And we tested that. There isn't any difference between the Northeast and, the Deep South, or Alaska for that matter. We're testing our Spanish in South America, Spain, and the US, across Guatemala and Peru and Colombia, different parts of the US, different Spanish speakers. There's no apparent difference, and not in accuracy studies that we have done.
Do you use any facial expression with the voice as well, or just purely vocal and speech?
So we're capable of doing multimodal biomarker analysis and having that be part of the algorithm build. And in MCI, we did use some other features beyond vocal. We used additional features and increased the accuracy from about 84% to 89 and 90% in accuracy for MCI. Alzheimer's, 98%, Huntington's, 98% or higher. Parkinson's, the same thing. We're doing MS right now. So in the progressive neurological disease area, there's so much engagement in the various construction of speech. There's so much engagement that the accuracies are very, very high. using multimodal things like facial expression or eyes or other things, gait analysis, for instance, is been used for cognitive health in some cases. And there are some others that we could. When you're 98% accurate, you're not going to tweak it much higher. So we don't add other things. It's very simple to capture voice. It's very easy to do it across multiple modalities, you know. We're even integrated into the Samsung Watch, for instance, effectively. We could do it on this video conference. We're integrated into Zoom, into Teams, and in Teledoc, telephone systems. So voice is such a natural way of communicating, and it's occurring between doctor patient, and we do it in an ambient mode, which means we're just listening to the conversation. We're not asking for a sample. So we listen to the conversation. We're capable of separating the voices, diarization. We're capable of doing speaker identification. We're capable of sample monitoring. So we know when we have enough sample. It can be 5 seconds here from the target, the patient. It could be 12 seconds. We put it all together. We're also monitoring for things like signal to noise and other things, indication that the sample might be noisy. So we can be patient and wait for more sample before processing. So we use AI to do all that, and are integrated into several other platforms. For instance, the Dragon Copilot, the new dictation platform. We're fully integrated into that and deploying with hospitals right now.
So you mentioned a bunch of conditions. I've heard a few neurologic, so Alzheimer's, Parkinson's, Huntington's. What about things like anxiety, depression, other some of the more commonplace conditions?
So we also have a range of behavioral health models: anxiety, depression, stress, mood, fatigue, energy levels. We also will launch PTSD shortly, and we're working also on postpartum depression. So when you think about the whole behavioral health area, think about that again as kind of a panel, you know. One of the things I did not mention was we have a pain model, we have an aggression model. The aggression model is being deployed in intelligent patient rooms. And the whole purpose is that we are doing um, on the CPU, so we're on edge. We don't no longer go to the cloud. We never leave the room. Our algorithm is deployed on the device. We're listening for levels of aggression up to 5 people in the room. So we determine where the aggression levels are, and we give the nursing staff a green, yellow, red light. The number of nurses attacked in the U.S. last year was hundreds a day. 20% of first-year nurses left nursing, and $20 billion estimated impact cost. So we're trying to provide them with a heads up in that case. And then the pain models, we're building that with NYU University Hospital. And in that case, imagine going from tell me where your pain is subjectively 1 to 10 to simply getting a reading, objectively reading that from their voice. And that is something that we'll launch late this year or beginning of next year.
And when you're sampling, do you sample just through the whole period of conversation, or you just take segmental and then analyze it as a segment for a final conclusion?
So once we have acquired in the conversation, once we've acquired 40 seconds from the patient, we will automatically process that in milliseconds and return it to device. The scores are returned to device. Now, all of the diseases I mentioned, any one of them could be measured on that 40 seconds or all of them at the same time. So we could be returning 4 or 5 different scores, like a blood profile, the voice profile. And so a doctor could be seeing a cognitive assessment, MCI, and Alzheimer's, at the same time seeing a behavioral assessment for anxiety and depression and fatigue. Those models receive CPT code reimbursement within the healthcare environment, and they're stackable codes. So they are providing the clinician with real-time assessment while they're speaking to a patient. What we're seeing is it's driving the conversation. A patient, depending on their age, I mean, if a patient is as old as I am, when someone says, "How are you doing?" My memory is, well, my dad crawled around during World War II in Italy. Yeah, this is a much better day than that. And so when they ask me, it's really governed by my perspective and my age and other things. Um, Different people may be having a different range. Subjectively, you can get a much different response, but from the central nervous system, it's an objective measurement.
Because when you interview a patient with an anxiety, as a part of many other things, the time can change. Like the beginning, they have feel of the trust and communication, then they can open up because the conversation can change. Oh, that's great. That's fantastic.
Imagine it's passive in the background too. So as a clinician, what I'm hearing from so many clinicians is, it's helping us be the doctors we were trained to be. We were trained to have conversations with our patients. And so often, there's so many things, there's a checklist of things for me to do. And I'm trying to go through that and interview them on that checklist. And the patient is getting more and more anxious potentially. Well, if you can take some of those checklist things like anxiety, depression, or cognitive health, and just simply do them in a normal conversation, you could be talking about fishing or the soccer game you went to watch. It doesn't matter what the nature of the conversation is. We're not measuring the words.
Could you walk us through a little bit about where you see this in the next, say, 6 to 12 months, and then down the road, where do you think this could go 5 years and beyond as we continue to improve on our capabilities?
So we've launched now in healthcare with Microsoft. While they're doing clinical dictation that on audio between a doctor and a patient, so you get a patient's dictation and a doctor's dictation. They're also providing within their AI structure other services, and Canary Speech ends up being a component of that AI platform. And what we're providing is then a sense of the individual's cognitive or behavioral health or other things, some of the progressive neurological diseases we talked about. We're working with hospitals that are doing from age 50 and on, they're doing a full panel of progressive neurological diseases. Accuracies for these are so high that if you're going to screen someone for MS, and MS often goes, as you know, undiagnosed for years, decades even. We're hoping that model, it'll launch late this year, will provide a screening that's an early warning screening, and then a referral can be made based on objective information. I think that's where we're seeing it. We're working with clinics that want to do that entire screening set or are using it for behavioral health, specifically behavioral health, and then we focus, of course. We're also deployed in like the Zoom platform for virtual healthcare, where you're at home, but you need a meeting and you sign on and you get to meet your doctor while you're sitting at your home. Canary Speech is integrated fully into that. And again, exactly like the interaction I talked about, it's just listening to the conversation. And so it's providing the doctor on their side with a panel of information about the patient. And that could be a psychiatric evaluation. It could be an evaluation for, a different type of disease. The doctor will choose what they do. It's a clinical decision support tool. And as a clinical decision support tool, it happens to have CPT code insurance reimbursement, but it provides information towards, in the array of information a doctor has to use, towards making a decision about next care, or referral or otherwise. And we're comfortable in that role. Remote monitoring for homes. I mean, our work with Samsung is to bring it into homes. On their device, we're integrated into their watch, we're integrated into their phone system, which they're deploying into home monitoring, so home care, extended care at home. We're a B2B, so we're integrated into other players that are providing services. And then, of course, adding AI and intelligence in situations like the patient room, to give alerts to clinical team members about potential risk situations. So it's a risk assessment in that case. I think our primary focus is in healthcare. We also have a presence in a range of other industries where, like in Japan, where licensing, you have the largest number of adults over the age of 100 and over the age of 90 and over the age of 75. They all have to take a cognitive assessment in order to get an annual license. Well, that cognitive assessment was bringing all these people, 10 million of them, into buildings to take a test. They're beginning to do that over the phone using Canary Speech. So that can streamline that process, reduce the cost to it and the inconvenience to the individual. They're always left with the opportunity to go into a center. So they have the choice, but they could do it effectively just in a telephone call.
And do you think if there's any, how can I say, abuse going to be, or some players, they take advantage of this technology? And I'm sure there's always bad character that can use this against whether a facility or a patient. Or what's your thoughts on that?
So whenever we're creating the next generation of technology, when I was in college, the first 2.5 years, we were using slide rules. Handheld calculators didn't exist. The Texas Instrument and the Hewlett-Packard things had not come out. Calculators had not come out. When they came out, the question was, well, would you use them to cheat on your exams, or can they be used in an exam in an appropriate and practical way? And the truth is, either could occur. And so for some period of time, there was caution on it and what type of calculator you could have. With respect to what we are doing in that bagel shop that I mentioned earlier, Jeff and I decided we were going to build a healthcare product, something that could be comfortably and practically held in the hand of a clinician or used in video conferencing. Under those circumstances, you build the company from the foundation, from the ground up, to accommodate the same requirements, same integrity, same knowledge of who we are working with, the patient, so that we're on par with, equal to, or better than any healthcare institution we work with. We're high trust, we're ISO certified, we're audited for all of those annually. We're audited by Microsoft. We have one of the first 10 companies to pass to be in their AI for good. You had to pass a whole bunch of things, but Microsoft is taking this very, very seriously, and so are we. So when you get into a healthcare environment and you're on par with the institution, then the welfare of the patient is paramount, and it's a consideration in everything they do. So we operate to guard that the patient's data is managed in a manner that has integrity behind it. On the other end of the sword, we don't distribute, where something could happen, we don't distribute our product or make it available. Everything to have our product and to use it requires keys and access that are only licensed to institutions that are functioning for reason. They're a healthcare institution and they're functioning that way. So we're very, very careful about that. But in this day and age, the ability to be careful about that is available. I mean, the kind of things we do, we spend probably 10% of our entire budget on making sure that we are data secure. And we're a little company. And when Microsoft approached us and said, we have this whole process, it normally takes anywhere from 6 to 8 weeks to complete. Our systems were on par with their systems. We finished their audits in 5 days. And I'm very proud of that, but we're equivalent to where they are. And the same is true of any hospital we're working with. So that's a necessary component of being in this industry. I think an individual company that wants to be here needs to take that seriously. and needs to have all the structures. And that goes all the way back. High trust includes our development process, our quality systems, our security systems, the requirements that we have for even the computer that you and I are talking on right now has multiple layers of security built into it. Sometimes that's a little irritating, to be quite frank, but it's a requirement.
You said the neurological and behavioral. How do you see this in daily, like clinical use in like internal medicine or surgery? How that can be uh, integrated as a daily tools? Is that going to be a part of the whole AI system, I believe?
Yeah, it is already incorporated into many AI systems, behavioral health, neurological health, all those are very, very obvious players. It wasn't as obvious to me where it might be in surgery and surgical health. I mean, obviously, you're concerned about an individual, an individual's behavioral health, their depression or their anxiety post surgery. You're always concerned about that. Um, in a recent conversation with a doctor at Hackensack Meridian, um, this question came up in general. We're having a kind of a meeting on process, and how it would be used. And someone said, well, what if you're a post-surgical patient meeting with their primary care doctor is told by Canary Speech that there's elevated depression or anxiety? Would you make a referral? And they said, well, if they're a post-surgical patient meeting with their primary care doc for the months after that they do, they would anticipate that they had elevated depression. They wouldn't make a referral. They would retain the clinical responsibility for helping the patient manage that. So those are decisions which fit into the whole process that's already there. And that's what you really look for. In surgery, I was also surprised as we're building this model for an objective measurement for pain, for instance. Post-surgical pain evaluation is done on a scale, as you're aware. Tell me where your pain is 1 to 10. And that's a very subjective thing. I mean, I was a distance runner when I was young. I'm not a Navy SEAL, which totally would be out of the scale. But as a distance runner, to be very, very good at it, and I was pretty good at it, I ran in the US Olympic trials. You had to be willing to put up with an awful lot of pain. That's just the art of running distances fast. So my pain scale is different than others, from training, from hundreds and hundreds of miles of training, 10,000 miles of training, and many, many races. So if you can move from a subjective measurement of pain to an objective measurement of pain, which we can, you now have an objective scale. When you ask a person, where's your pain level? Objectively, we're measuring it against the central nervous system's response, and which is an objective, probably truer measurement of where an individual's pain level is. We also found in that study that, remember I mentioned we have 2,590 features we look at. Well, in the measurement for pain, the algorithm selectively built it against about 298 features of that 2,590. Every set is different. Every specific application is different. Huntington's disease uses 1,103 of them, for instance. So this is 298 when a person is talking about the pain they have right now. When you looked at the question, tell me how this compares, think about a pain level you had during the last 2 weeks. And they describe where they are with that pain level, talking to the clinician. There was 196 features which the algorithm was built from, and only 20% of them were the same as the other question. So when you think about selectivity, that's how selective these voice features are. This is a person remembering where their pain was, and it makes sense when we talk about it, and where their pain is now. And we're going to separate the two of those. So that's where the future of what we're doing, we're going to see really, I think, developing now great selectivity. And every objective piece of information you give to a trained clinician or clinical team augments their ability to serve that patient and hopefully improves their outcome and becomes a force multiplier for them. So that's, I think, what our hope is. Our vision is give a tool to the clinician that allows them to make more objectively driven decisions.
This could be huge in oncology for tracking pain. We have we use these scores and track them. They're part of our quality metrics, but it's always a challenge because it's a very, as you said, this pain score 1 to 10 is a very subjective, or 0 to 10 is a very subjective measure, whereas some type of objective data would be incredibly helpful to be able to both assess, track, and then adjust pain meds.
And imagine while you're measuring their pain level, you also were measuring their anxiety, depression, and fatigue level. And so you're looking at 4 pieces of objective information at the same time. So particularly with cancer patients in between, say, chemotherapy, or even X-ray therapy, have they recovered? And they're never fully recovered, as you guys are aware. But are they just in the doldrums, and should you be making adjustments based on their fatigue level and their anxiety, depression levels? And when we were working with the Harvard doctors, the neurology team there, we were measuring Huntington's and Parkinson's. And there was a conversation about, why don't we toss in the behavioral health, anxiety, and depression in that mix? And what was coming back was individuals who anxiety and depression levels were off the chart. And their focus was their neurological disease. And all of a sudden they were going, wow. And so they started making referrals for these individuals and getting them into either a psychiatrist or a psychologist, and helping them manage their life better, So those are the kind of things. David Rue, global chief medical officer for Microsoft, talks about opportunistic screening. And if you have a group of things that are on your list to look at, and half of them get checked through the conversation that you're having with the patient, it frees you up to have further conversation with the patient, So that's the kind of thing we're seeing happening as we're rolling the product out and engaging with more clinicians. Remember, the other thing is that nothing we built is built independent of that. It's all built in that environment. So that it would be impossible. My background, I did research in neurological diseases, and that's 40 years ago, when we were basically still in caves, So as we transitioned out of caves, to think that we could develop this independent of the wisdom and the experience and the expertise of the teams we work with would be impossible. You have to have that.
Yeah, I think as a clinician, is sometimes we focus on a major problem, and you can miss what's in the periphery, sometimes, whether it's dose or whether it's an element of medication or other things. But it's great as bring somebody that through that things be able to tell, hey, this person, not only that, there is some anxiety, some depression, or other things that can be picked up early, because sometimes the conversation get on. I'm sure with chemo, Rob can tell this, you're focusing on the dose of medicine or the things, but then you're missing sometimes the behavioral or the pain. And that's I think that's amazing. That's fascinating. So where this is going to help us in future.
One of the other practical things is that it doesn't matter whose hand it's in. From one clinician to the next, it's going to give the same opinion. It's going to give the same information. So you have this consistency across the group, and it's kind of nice in talking to clinical teams that are using it, and they just feel it's making them better. It's giving them the time to talk to their patients. It's so simple to do. It's the most natural thing we do, and in some cases, like me, probably too much of it, too much talking. But it allows us to simply gather information and present that while you're still with the patient. And the goal was to make something practical that could impact on the interaction between the doctor and the patient. Ambient listening allowed us to get there. Previously, we had to ask for a 40-second sample, which meant you had to take time, or you had to ask them to do it. When we got to ambient listening, where we could simply and non-intrusively capture the information, then that became a practical component of the clinical care.
I personally has been using AI on my visit with my patient in the past couple of months. That has tremendously improved direct conversation instead of taking notes or having somebody scribes stuff like that. Then later on you look at that, oh, it says this is what the patient says, or this is what's going on, and then the conclusion adds a lot more. And beside that, I think the interaction with the patient make it more personal and more, eye to eye contact, while you don't have to write and you don't have to look at the computer. So I'm just at the beginning. I think these are fascinating. I think this is the frontier of medicine, and I think it's all hopefully for the good.
I was gonna add that I think we have a component of the medical tricorder here. It's we've been talking about this for since the Star Trek in the 60s. This tricorder, this device that can be wand the doctor has, and now we have all these tools. But this is really fascinating to have using the speech, simply the sound that and the to be able to gather this information and aid clinicians, nurses, and other healthcare providers. I think it's phenomenal. I think this could be integrated into many different care settings.
Mm-hmm. I was talking with Samsung today. I mentioned earlier that we're on the Samsung watch. Well, that's a really narrow statement, because there is a little canary on the Samsung watch, and you can click it and you can do what we do from the watch, just talk to the watch, And but the narrow vision is that we can also capture the heart rate, the pulse, the temperature, and a whole range of other things that Samsung is looking for. How many hours of sleep they had last night, those kind of things. All of that could be in this multimodal mode that you were talking about earlier. All of that could be brought in real time and augment what we're doing. So I think we haven't built that yet. I mean, we'll work on doing that. We're adding new languages, Arabic and Dutch and some other languages, and then the new diseases that I spoke about. But adding multimodal things, bringing this all together. And then the other aspect is LLMs provide information. We're not using LLMs. We use discrete data. And the simplest way, simple mind, the simplest way to look at it for me is that LLMs look at hundreds of thousands of patients where conversation was similar, the primary mode, conversation, the words that being spoken are similar. Diagnosis associated with that and conditions associated with that can then be pulled out to give you some kind of a measurement, some kind of a probability that the person you're talking to may also have the same disease as hundreds of thousands of others that have been in similar situations. Again, it's subjective, because it's not about the patient in front of you other than the words they're speaking. It's not their specific disease. What Canary Speech does is it's listening to the audio of that individual and the characteristics of their speech, not 100,000 others, but their speech, and producing a similar correlation or score for the likelihood that they have Parkinson's. LLMs may say the likelihood that they have Parkinson's is also elevated, but the two pieces of information together within science, medical science or otherwise, coming from two different angles, give you a stronger likelihood of success with respect to accuracy. So I think that's coming together now also. And you see that in the AI platform that Microsoft is offering in the Dragon Copilot. Their ability to go get that information at the same time they're capturing Canary Speech's information allows the clinician potentially to see multiple modes of information in order to make a decision about the care of the patient.
Could you talk a little bit about false positives, and how do you deal with those? And is this the data set so huge that those kind of get weeded out in the whole process?
Well, the very high accuracy models, 98, 99% accuracies have very, very little. And these are clinical decision support information. They're objective. It's nice to have them, but ultimately the doctor looks at them, given their expertise, given their experience, given the other things they're seeing at the same moment, it becomes a component of their decision about how to treat the patient, what the diagnosis is. The diagnosis is made by the doctor. So false negatives and false positives are elements of any measurement. And what you try to do is you try to minimize those through training. In our case, training, experience, reducing the impact of noise. All those things are all built into the models. Training across all 50 states, so you're taking into account different noise characteristics, different accents, different voices, which we don't think impacts on it. But nonetheless, you train it because we're scientists. That's what you do. And when you combine that with LLM, that's one of the beauties you have, because they're going to have potential false negatives or false positives. However, they're looking at it from a different angle. And so now you have these two different angles looking at it, and you can compare those pieces of data. And probably the best machine learning tool currently on planet Earth is right in the head, right here. They're looking at all these pieces of information and their experience and 100,000 other things come together in milliseconds for them to make a decision about the next appropriate treatment for a patient. And that's where I think we really have to depend on the expertise, the training, and the experience of the individuals that we trust, and try to augment their ability to do that effectively and efficiently. That force multiplier I was talking about. Make the information available to them in real time.
And I think this would save a lot of unnecessary tests. So when you start focusing whether it's behavioral or whether it's cognitive or whether I think just it helps the clinician to focus sharper on the real disease and hopefully to get to the solution much faster than value of the test. And you're hoping for the blood test, maybe save some money as well, which with more accurate diagnosis.
Yeah, what we're trying to do is to make in that time the patient and doctor are together, make available as much useful information, objective information as you can, so that the doctor can take that into account in their decision making concerning patient's welfare.
You mentioned a little bit earlier about languages, and I was just kind of fascinated by that. It's do you have to create a new model for every language, or do elements carry over from language to language, or groups of languages?
So it's very interesting. We don't pay attention to the language that's being spoken or the words that are being spoken at all. However, we do train in all of the languages because, again, we're scientists. You don't just assume. But there is all types of tools in machine learning. Transfer learning is the biggest one, where I can take the model. We built MCI in Japanese first. So we took the model, the algorithm that we built for Japanese in MCI, and when we were building the models here and validating the models here, the starting point was that algorithm. So we had a starting point to work with. We're doing the same thing now with MCI and Alzheimer's in Dutch and in Arabic, because how the central nervous system, the deficits or the defects that are created by, say, MCI and Alzheimer's, impact on the central nervous system's ability to control the various instruments that create speech. But they do so in a very apparently similar way. And the consequences are that the algorithms are very, very much the same. So we validate across all languages, but to validate, if we have an existing model, to validate in a new language takes about 4 weeks, and a sample set that's 30% of what the other training sample set had been for validation purposes. So it can move along reasonably quickly.
So for the listeners, MCI is minor cognitive impairment.
Yeah, often seen as a precursor to a range of cognitive illnesses. The most prevalent is Alzheimer's disease. So it's mild cognitive impairment is often seen as a precursor. It can occur anywhere from months to years before you get cognitive illness like Alzheimer's disease.
Which is really interesting because patients are much more likely to present to a primary care or have a telehealth visit or some type of interaction, but probably not with the neurologist as they're until they're much more advanced.
Yeah, and I often I often say two things. One is you don't need a canary speech model to tell a person has advanced Alzheimer's disease. And quite frankly, a canary speech model is much more valuable in the hands of a primary care doctor than in the hands of a neurologist who's seen a patient because they've been referred with cognitive problems. So the screening level where particularly like think about MS or even autism and ADHD, the the doctor that's seeing them is either a pediatrician or a primary care doc in all of those cases. Children, of course, pediatrician, and their specific training isn't necessarily the specialist level. And the consequences are that if you can provide them with a model, a tool that says to them there's an indication of MCI, mild cognitive impairment, it's an aha moment for them, you know, and they know the patient often for years that's in front of them. They've known him for years, and it clicks. They make the decision based on that information. Should I make a referral or not? And ultimately, that's a decision that they're going to make as a doctor.
It is fascinating. This is amazing. What is the frontier of the medicine is? I have learned a lot. So
I would just I would venture to say that when we spoke a few weeks ago, you mentioned that Jeff was sadly no longer with us, but I venture to say that he would be very proud of what you and everyone at Canary is doing.
We're friends for 40 years, good friends for 40 years, and his wife very kindly left his phone active, and so once every couple of weeks I call and leave him a message, just bring him up to date.
that's fantastic. That's good friendship. Tell us how you can find you if anybody interested in the technology and further information, how the audience can find you.
We can be found at www.canaryspeech.com. It's easy to reach me. I'm Henry, and all of our emails are henry@canaryspeech.com. It's pretty straightforward. The website is going to give you basic information about the company. If you have any questions, don't hesitate, send them to me. I love it. I'll answer everything I can, and if I can't, I'll refer it to one of our team members, our chief technical officer or a head of our engineering or something.
Well, thank you for your time. Greatly, I appreciate it, and hopefully we can revisit maybe 6 months, year down the line with updates and this fascinating technology and learn more about it.
Well,
Thank you for what you're doing.
Well, guys, it was wonderful to speak with you. Thank you.